sleeve, how does it work? You must understand how this sleeve works now. Are you getting me now? Now, the whole system works by what we call induction or conduction. Good morning. Welcome back to class. So, what to discuss on electricity, static electricity, static what? Static electricity, right? So, static electricity is something that we have worked on already, and we just want to continue on, you know, some of the things we have said, all right? So, what are the things we have discussed? We have been able to discuss that in static electricity, we talked about Coulomb's law. Coulomb's law, I would say that Coulomb propounded a law that is very important. He said K Q1 Q2 over Q2. This formula is just to, describe the force that is acting between two charges. I'm talking about two charges. We said there are two kinds of charge, either positive or negative. I would say there is what we call electrostatic force, okay? That force is the force of attraction, alright, between two charges, alright? Now, if those two charges are the same, let's say we have a plus and a plus, there will be a kind of repulsion, alright? They are not going to attract, you understand me? But if they are opposite charge, there will be what? Attraction. We've said all that, and I will advise you to go to the YouTube page or the, TikTok and go and watch those videos so that you update yourself. I just want to continue on where we stopped earlier, alright? So what to look at, the aspect we want to look at is road leaf electroscope. Road leaf electroscope is very, very important, you know, something or parameter to understand when we talk about static electricity. Alright? So why is it important? How do we know that something is charged? Now this is not a conductor. This whiteboard marker is not a conductor. How do we find out if this board is charged or not? And even if it's charged, how do we know if it is negative or positive? That is where road leaf electroscope comes in. Alright, it's an instrument for you to be able to detect whether a body is charged at all, and if it is charged, whether it has a positive or negative charge. I hope you are following me now. Road leaf electroscope. So let's have a diagram of what our road leaf electroscope is. I would have drawn the outline on the board before I started the video, but I want to show you how to go about the diagram so that it's very easy for you. I don't want any hocus pocus. I want it to be very simplified so that you can understand it. Okay, so follow me as we have a diagram of our road leaf electroscope. So what we need for a road leaf electroscope is to just have something like this. Alright, are you with me? So just have something like this. Then you have a small closing like this. Are you with me? Okay, then you draw another small box here. Then another small box here. Alright, okay, are you there? Then you kind of like put a stripe on it. A stripe on it. Are we together? I hope you are following me. Are you getting it? Then we now have, our rod. Okay, our rod can be this way. Then the rod will also extend upward. Then the rod has a cap. The rod has a what? A cap. How many of you are following me? I hope you are getting it. Can you see how beautiful my electroscope is looking like? Alright, so we now have our leaf. This is the main important thing in this road leaf electroscope. Can you see? Alright, so in case you still need to rewind the video so that you can see how beautiful it is and how to draw it on your own, because that's the target. I want you to be able to draw a diagram on your own for those that are writing white. Alright, so what else do we have here? Then we have what we call X. Your X can be this side or the other side. So let's put our X at this side. So what is X? X simply means, a conductor that will touch, that will connect to the X. Okay? Alright, are we together, please? So this is our road leaf electroscope. Can you see how beautiful it's looking like? So it's very easy for you. Like I said, you can always rewind the video to understand how to draw something like this on your own. Okay? So let's draw a label. Let's start labeling it. So like I said, this is a cap. And what kind of cap is this? So it could be it's a brass cap, alright? Then this is an insulator. That's why you see the stripe there. It's an insulator. In our last video, what is it? An insulator. An insulator is any substance that does not allow the flow of charge. So we insulate this place so that there will not be conduction of charge. We are making use of this so that the charge will not be conducted away. Are you getting me? Alright, so this is an insulator. Then of course this is also our brass rod. I call it a brass rod. I will together please. I hope you are enjoying the class. Can you see my right up? This is what? A brass rod. Okay? Then this is gold leaf. That's the most important aspect of the whole diagram. Gold leaf. Alright? Gold leaf. It could be gold leaf or aluminium leaf. Alright? Are you with me? So this is earth, or you can call it earthing. So like I said, this earthing or earth is just a conductor that will connect to the earth. You understand me? Are you getting me now? So what else do we need to look at? Okay, this is a case. This case can be metal or glass. A metal case or what? Are you with me? Or a what? A glass. Either metal or glass case. Okay? Metal or what? Let me just limit at metal. But most times it's glass. Why do we use glass? So that it can be transparent. Alright? And you can see whatever is happening there. Now, we have learned how to draw our gold leaf electroscope. So, when you are doing them, you can put up an outline like this, and all this drawing could be with just it could be left vacant so that you can fill in the space, or you identify all these portions that I just labeled now. Alright, so after identifying it, it's very important for you to know the function. So what's the function of this app? This is an app that does the major work. Alright, so this outline, the function of this outline, like I said, is to detect if anything is charged at all, and when it is charged, to detect whether it's what? A positive charge or what? A negative charge. Then after you have detected whether it's a positive or negative charge, you also have to know whether your material is a conductor or an insulator. Are you with me now? So that's the work of this diagram you are seeing here. You understand what I'm saying? That's the work of this diagram you are seeing here. Are you getting me now? So this brass cap does the major work. Are you getting me now? You just bring your whatever. Let's assume that I have a material now, and I want to detect whether this material is what? Whether it is charged, and if it's charged, whether it is positive or negative. I'll bring this material close to this brass cap. So it's this brass cap that will be receiving it. This is the receiving end. You understand? So once you receive the charge, are you getting me now? This one will be responding. This is a conductor. This one is like conducting whatever it has received here. And this part will be responding. This is the golden electroscope. That's why I say this is the most important part of what? The whole outline you are seeing here. Are you getting me? I hope you understand. So this outline is what? Electroscope. So we call it gold leaf electroscope. Electroscope. So you can call it any other thing. You can say aluminum leaf electroscope, but I know that the primary name for this outline is what? Electroscope. Are you getting me? So this gold leaf is because of the leaf we will have. So now this leaf, how does it work? You must understand how this leaf works now. Are you getting me now? Now the whole system works by what we call induction or conduction. Are you getting me now? Induction or conduction. And in my previous video, I discussed about induction and conduction. Alright, let me give you a small gist. But if you want to get the full detail, you will have to go back to the previous video, either in our TikTok or YouTube. Now, what is induction? Induction is a way of charging by just bringing it close to each other. So let's assume that my hand is positively charged and this other hand is not charged at all. and both of them are non-conductors. You know, as they are now, they are conductors, right? So let's assume they are non-conductors. Something like plastic. Are you getting me now? So once this one is charged, let's say it's charged positively. Are you getting me now? And I bring it close to this other non-charged plastic. I just bring it very close now. After some time, the electric field around this one will affect this one. This one will not be charged. But with what? The opposite charge. This is positive. This one will be charged what? Negative charge. I hope you understand me. Just by bringing it close, they must not come in contact with each other. That is charging by what? Induction. So charging by conduction is when you have to bring them together. This is positive charge. You do not have to charge this other part. And they will be charged with the same charge. This one is positive. This one will not be charged with what? Positive charge. Are you getting it now? So they are totally different methods of what? Charging. So this is going to be the electroscope. You know, respond to both charging by induction and by what? Conduction. Are you with me now? I hope you are following the class. So what next? What next is that we're looking at how to, you know, detect what kind of charge is in this module now. Are you getting me now? So how do you find out? Number one, if our module electroscope, we have to charge it. We have to what? Charge it with a known charge. We have to charge it with either positive or what? Negative. Are you getting me now? Alright? So before you charge it, you have to earth it. That is connected to the ground so that any charge at all will be lost. Alright? Then we now charge it. We bring something that is known, we bring a known charge either by conduction or induction and charge it. So let's assume we have charged this with what? Negative charge. Are you getting me now? We have charged our what? Rodin electroscope with what? Negative charge. Then we now bring another body that is what? Charged. Let's say this one is also charged with what? Negative charge. Are you getting me now? Are you with me? Now, by the time you bring this body in contact with this golden electroscope, remember, we must charge our electroscope with a known charge. Now, we know that the charge here is what? Negative. You bring this body that is charged, we don't know what it is. We don't know what it is. I know you are saying minor, but we say we don't know. Like, we are assuming that we don't know. By the time we bring it close to this electroscope, now this electroscope will respond in a particular way. This leaf, are you getting me, will close up if this body that is brought in contact with it has this opposite charge. Now, as is negative, if this one has a positive charge, if you bring it in contact with each other, the leaf will what? Close up. You understand that? It will close like this. You will have this diagram like this. So it has closed up. It's not open anymore. Why? That is how to respond if they are having opposite charge. That is, this one is minus and you have a positive charge at the other end. But if they are the same, like you are seeing now, and let's assume you don't know, but let's say you are seeing it now. Alright? So if they are the same, what will happen? The leaf will open up. The leaf will open up in this manner. Are you getting me now? Do you understand that? So that is how to detect whether the body in question is in positive or negative charge. The first procedure is that you have to charge your what? Electroscope. Are we together now? Alright, so now how do we detect if there is charge at all? Like I said, you can see if the leaf open or close. You can now know whether the body is charged. Now how do you know whether it's a conductor or an insulator? Now, the level of opening and closing is what tells you whether it's a conductor or what? An insulator. Are you getting it now? This dog will not die today. Let me walk. I have all the time in the world. No, I don't need to pass. I'll pack it out. Let me feel like you left, so. You can flex money, you can use that forever. That no, you don't be happy. But okay, we don't open that one now. I have all the time in the world. You're walking up and down.
But this thing wey dey inverted like this, so no go dey show inverted.
So now, just like what I wanted, the God is not, you understand? So what I'm going to do next, I'm going to relate to the God that is like I put it straight. You understand?
Okay.
Oh, what that's not true. Only that stuff. So now you know how to make use of your what? Your good lead electroscope. I get it now. So now, like I said, if you want to know if it's a conductor or what, insulator, the degree of what opening and closing will tell you whether it's a conductor or an insulator. Are you with me now? So if it's a conductor, the opening will be very fast, or the closing will be very fast. Are you getting it? It will respond very fast. That is to show that this is the one conductor. I get it now. Remember, they will be brought in contact with each other. Alright? So the opening will be very fast, and the closing will be very fast. This is a conductor. But if it takes time before it closes or opens, then we can now say that it is what? An insulator or a non-conductor. Now you know your good electroscope very well.